Hello viewers, welcome to our channel Career Prep. Mensuration is an important and scoring topic of the quantitative aptitude section in competitive exams like GRE, GMAT, SSC, RBI exams, railway exams and so on. In this video, we'll solve a few problems on 3D shapes. There are different formulae to solve questions on this topic. So knowing and applying these formulae is very important to do well in this section. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. The radius of a sphere is 9 centimeters. It is melted and drawn into a wire of radius 0.3 centimeters. What is the length of the wire? Here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find the length of the wire. Now you know that a wire is cylindrical in shape. So length of the wire would be nothing but the height of the cylinder. So if we find out the height of the cylinder, then we'll know the length of the wire. Now it's given that the radius of the sphere is 9 centimeters and radius of the wire is 0.3 centimeters. Now it's given that the sphere is melted and drawn into a wire, which means the volume of the sphere is equal to the volume of the wire. Now volume of the wire is nothing but volume of a cylinder, since wire is cylindrical in shape. Now we know that volume of a sphere is 4 by 3 pi r cubed and volume of the cylinder is pi r squared h. So now we have 4 by 3 pi r cubed is equal to pi r squared h. Substituting the values of the radius of sphere and radius of the wire in the equation, here we get 4 by 3 multiplied by pi multiplied by 9 cubed is equal to pi multiplied by 0.3 multiplied by 0.3 multiplied by h. Now the pi on the left hand side and the pi on the right hand side gets cancelled out. So now we are left with h is equal to 4 multiplied by 9 multiplied by 9 multiplied by 9 divided by 3 multiplied by 0.3 multiplied by 0.3. On solving this, we get h is equal to 10,800 centimeters. Now since all the answer options are given in meters, we have to consider the height in centimeters to height in meters. So divide this by 100. So 10,800 centimeters divided by 100 is 108 meters. So height of the cylinder is 108 meters, which means the length of the wire is 108 meters. So the correct answer is option B, 108 meters. A solid metallic sphere of radius 10 centimeters is melted and recast into spheres of radius 2 centimeters each. How many such spheres can be made? So here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find out how many spheres can be made if a solid metallic sphere of radius 10 centimeter is melted and recast into spheres of radius 2 centimeters each. So here it's given that the radius of the big sphere is 10 centimeters and radius of the small sphere is 2 centimeters. Now since the big sphere is melted and recast into many small spheres, this means that volume of the big sphere is equal to n multiplied by volume of small spheres. Here n is the number of small spheres. Now we know that the formula for volume of a sphere is volume of a sphere equals 4 by 3 pi r cubed. Now we know the radius of the big sphere is 8 centimeters and the radius of the small sphere is 2 centimeters. So now we have 4 by 3 multiplied by pi multiplied by 10 cubed is equal to n multiplied by 4 by 3 multiplied by pi multiplied by 2 cubed. Here 4 by 3 pi on the left hand side and 4 by 3 pi on the right hand side get cancelled out, and we are left with 10 multiplied by 10 multiplied by 10 is equal to n multiplied by 2 multiplied by 2 multiplied by 2. On solving this, we get n is equal to 125, which means 125 small spheres can be made when the big sphere is melted and recast. So the correct answer here is option C, 125. A cylindrical vessel 60 centimeters in diameter is partially filled with water. A sphere 54 centimeters in diameter is gently dropped into the vessel. To what further height will the water rise in the cylinder? Here you're given four options and you have to find out which of these options is the correct one. So here you're asked to find to what further height will the water rise in the cylinder when a sphere is gently dropped into the vessel. Now look at this diagram. This is a cylindrical vessel. This is partially filled with water, that is till here. So this is the original height of the water in the vessel. Now a sphere is gently dropped into the vessel. When the sphere is dropped into the water in the cylindrical vessel, the level of the water increases. So if this was the original water level, now the water rises to this level. So this is the new level of water in the vessel. So this is the original height of the water. This is the new height of the water. Now we are asked to find to what further height will the water rise in the cylinder after the sphere has been dropped into the vessel, which means we have to find this height. Let this height be h. So we have to find the value of h. Now it's given that the diameter of the cylinder is 60 centimeters. So radius of the cylinder R1 would be equal to 60 divided by 2, that is 30 centimeters. It's given that diameter of the sphere is 54 centimeters, which means radius R2, the radius of the sphere would be equal to 54 divided by 2, that is 27 centimeters. Now, when the sphere is dropped into the water contained in the cylindrical vessel, there will be an increase in the water level. This increase in the volume of water will be equal to the volume of the sphere dropped. This increased volume can be seen as a cylinder, and this is shown in light blue color in this diagram. Now let the increase in height be equal to h. So here the volume of the sphere is equal to volume of the water raised in the cylindrical vessel. Now we know that the volume of a sphere is equal to 4 by 3 multiplied by pi r cubed, and volume of a cylinder is equal to pi r squared h. So here volume of the sphere would be equal to 4 by 3 multiplied by pi r2 cubed, and volume of water raised in the cylindrical vessel would be equal to pi r1 squared h. Now we know the value of R2 is 27 centimeters. Value of R1 is 30 centimeters. So now we have 4 by 3 multiplied by pi multiplied by 27 cubed is equal to pi multiplied by 30 squared multiplied by h. The pi on the left hand side and pi on the right hand side of the equation gets cancelled. So now we have h is equal to 4 multiplied by 27 multiplied by 27 multiplied by 27 divided by 3 multiplied by 30 multiplied by 30. On solving this, we get h is equal to 29.16 centimeters, which means the water has risen in the cylinder to a further height of 29.16 centimeters after the sphere has been dropped into the uh, vessel. So the correct answer is option C, 29.16 centimeters. In the toy shown in the adjoining figure, the height of the cone is 15 centimeters, total height of the toy is 40 centimeters, radius of the hemisphere is 7 centimeters. Find the volume of the toy. The value of pi is 22 by 7. Here you are given 4 options and you have to find out which one of these is the correct option. So here you are asked to find the volume of the toy. Now look at this toy. Clearly here you can see that this toy has a conical top, a cylindrical body and a hemispherical base. So the volume of this toy is equal to volume of the cone plus volume of the cylinder plus volume of the hemisphere. Now it's given that the total height of the toy is 40 centimeters. So AH is 40 centimeters. Height of the cone is 15 centimeters. So AD is 15 centimeters. It's given that the radius of the hemisphere is 7 centimeters, which means EH is 7 centimeters. So we know AD is 15 centimeters, EH is 7 centimeters, and AH is 40 centimeters. So clearly DE is equal to 40 minus 15 minus 7, that is 40 minus 22, which is 18 centimeters. So the height of the cylinder is 18 centimeters. Now look at this diagram. Here EG is also the radius of the hemisphere and EG is equal to 7 centimeters. Now here EG is also the radius of the cylinder, which means the radius of the cylinder is also 7 centimeters. Now clearly here you can see that EG is equal to DC, which means DC is 7 centimeters. Now here DC is the radius of the cone. So the radius of the cone is also 7 centimeters. So in this toy, the radius of the cone is 7 centimeters, radius of the cylinder is 7 centimeters, and radius of the hemisphere is also 7 centimeters. Now let's find the volume of the toy. So volume of the toy is equal to volume of the cone plus volume of the cylinder plus volume of the hemisphere. We know that volume of cone is 1 by 3 multiplied by pi r squared h. Volume of cylinder is pi r squared h. Volume of hemisphere is 2 by 3 multiplied by pi r cubed. So substituting the values here, we get volume of the toy is equal to 1 by 3 multiplied by pi multiplied by 7 squared multiplied by 15 plus pi multiplied by 7 squared multiplied by 18 plus 2 by 3 multiplied by pi multiplied by 7 cubed. Now here 49 pi is common in all these three terms. So now we have volume of the toy is equal to 49 pi multiplied by, now here you have taken 49 pi as common. So you're left with 1 by 3 multiplied by 15, which is 5. Now here you have taken 49 pi as common. So you're left with 18. Here after taking out 49 pi as common, you are left with 2 by 3 multiplied by 7, which is 14 by 3. So now you have volume of the toy is equal to 49 pi multiplied by 5 plus 18 plus 14 by 3. Now substituting the value of pi as 22 by 7 and solving this, we get volume of the toy as 4260.67 centimeter cube. So the correct answer is option B, 4260.67 centimeter cube. If the radius of a hemispherical balloon increases from 5 centimeters to 10 centimeters as air is being pumped into it, find the ratio of the surface areas of the original balloon to that of the inflated balloon. Here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find the ratio of the surface areas of the original balloon to that of the inflated balloon. Now it's given that the radius of the hemispherical balloon originally is R1, which is 5 centimeters. Then air is pumped into the balloon. Then the radius of the inflated hemispherical balloon is R2, which is given as 10 centimeters. Now we are asked to find the ratio of the surface areas of the original balloon to that of the inflated balloon. Now we know that the total surface area of a hemisphere is 3 pi r squared. So the ratio of the surface areas of the balloon in the two cases is equal to 3 pi r1 squared divided by 3 pi r2 squared. The 3 pi in the numerator and 3 pi in the denominator gets cancelled out. And we are left with r1 squared divided by r2 squared, which is 25 divided by 100, which is nothing but 1 by 4. So the required ratio of the surface areas of the original balloon to that of the inflated balloon is 1:4. So the correct answer is option C, 1:4. A sphere is cut into two equal halves and both the halves are painted from all the sides. The radius of the sphere is r units and the rate of painting is rupees 8 per square unit. What is the total cost of painting the two halves of the sphere in rupees? Here you are given 4 options and you have to find out which of these options is the correct one. So here it's given that a sphere is cut into two equal halves and both the halves are painted from all the sides. So this sphere is cut into two equal halves, that is, the sphere is cut into two hemispheres and both these hemispheres are painted from all the sides. Now it's given that the rate of painting is rupees 8 per square unit and you're asked to find the total cost of painting the two halves of the sphere. So as you can see here, both the hemispheres are painted from all the sides, which means the flat surface area of both the hemispheres is painted plus the curved surface area of both the hemisphere is painted. Now the curved surface of both the hemispheres is equal to the curved surface of the sphere. So what is painted here is the curved surface area of the sphere and the flat surface area of the two hemispheres. Now we know that the curved surface area of a sphere is equal to 4 pi r squared. Flat surface area of two hemispheres is equal to 2 multiplied by pi r squared. So total surface area is 6 pi r squared. So total surface area of 6 pi r squared is painted. Now it's given that the rate of painting is rupees 8 per square unit. That is, for 1 square unit the rate of painting is rupees 8. So for 6 pi r square units, the total cost of painting would be rupees 8 multiplied by 6 pi r squared, which is rupees 48 pi r squared. So the total cost of painting the two halves of the sphere is rupees 48 pi r squared. The correct answer is option C, 48 pi r squared. The base of a prism is a triangle of sides 3, 4 and 5 meters respectively. The height of the prism is 10 meters. Find the volume of the prism. Here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find the volume of the prism. Now we know that volume of the prism is equal to base area multiplied by height. Now height of the prism is given as 10 meters. So if we find out the base area, we can easily calculate the volume of the prism. Now here, since the sides of the triangular base are given, we can find the base area of the prism by using the formula base area is equal to square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c, where s is equal to a plus b plus c divided by 2. Here s is equal to 3 plus 4 plus 5 divided by 2, which is nothing but 6. So s is equal to 6 meters. Now substituting the value of s in the formula here, we get base area is equal to square root of 6 multiplied by 6 minus 3 multiplied by 6 minus 4 multiplied by 6 minus 5. On solving this, we get the base area as 6 meters squared. So now we know the base area is 6 meters squared and height of the prism is given as 10 meters. Substituting these values in the formula here, we get volume of the prism is equal to 6 multiplied by 10, which is 60 meter cubed. So the correct answer is option A, 60 meter cubed. The base of a prism is a right-angled isosceles triangle whose hypotenuse is 3 root 2 centimeters. The height of the prism is 12 centimeters. Find the volume of the prism. Here you are given 4 options and have to find out which of these options is the correct one. So here you are asked to find the volume of the prism. Now you know that volume of a prism is equal to base area multiplied by height. Now height of the prism is given as 12 centimeters. So if you find out the value of the base area, then you can easily calculate the volume of the prism. Now look at this diagram of a prism. Here you can see that the base of this prism is a right-angled isosceles triangle. Here it's given that the hypotenuse of this right-angled isosceles triangle is 3 root 2 centimeters. Now in an isosceles triangle, the two sides are equal. Now let these two sides be equal to A. Now since this is a right-angled triangle, we can use the Pythagoras theorem to find out the value of the sides. So according to the Pythagoras theorem, 3 root 2 squared is equal to a squared plus a squared. On solving this, we get a is equal to 3. So in this right-angled isosceles triangle, AC is equal to A. This is the base and A is equal to 3. So the base is equal to 3 centimeters. Now AB is the height of this triangle. AB is also equal to A, which means the height of this triangle is also equal to 3 centimeters. So in this right-angled isosceles triangle, the base is equal to 3 centimeters and height is equal to 3 centimeters. Now we know that area of a triangular base is equal to half multiplied by base multiplied by height, which means area of the triangular base is half multiplied by 3 multiplied by 3, which is 9 by 2 centimeter squared. So now we know the base area is 9 by 2 centimeter squared. Height of the prism is given as 12 centimeters. So substituting these values in the formula here, we get volume of the prism is equal to 9 by 2 multiplied by 12, which is 54 centimeter cubed. So the correct answer is option A, 54 centimeters cubed. What will be the surface area of the prism if the length, breadth and height of the prism are 8 units, 6 units and 4 units respectively? Here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find the total surface area of the prism. Now we know that the total surface area of a prism is equal to area of the two bases plus the lateral surface area of the prism, which means the total surface area of a prism is equal to 2 multiplied by base area plus base perimeter multiplied by height. Now height of the prism is given as 4 units. So if we find out the value of the base perimeter and the value of the base area, then we can easily calculate the value of the total surface area of a prism. Now it's given that the length is 8 units, breadth is 6 units and height is 4 units. Now with this information it's clear that the prism is a rectangular prism, which means the base of the prism is a rectangle. Now since the base of the prism is a rectangle, the base area would be equal to length multiplied by breadth, which is 8 multiplied by 6, which is nothing but 48 units squared. So base area is 48 units squared. Now since the base is a rectangle, the base perimeter would be equal to 2 multiplied by L plus B, which is 2 multiplied by 8 plus 6, which is nothing but 28 units. Now we know that the base area is 48 units squared, base perimeter is 28 units and height of the prism is given as 4 units. Let's substitute the values of the base area, base perimeter and height in the surface area formula. So now we get surface area of the prism is equal to 2 multiplied by 48 plus 28 multiplied by 4. On solving this, we get the total surface area of the prism as 208 units squared. The correct answer is option B, 208 units squared. Viewers, please go through this video till you have understood the concept. Practice more such problems to increase your speed and also to understand the concept clearly. If you have liked this video, please like, subscribe and share this video. Thank you.